Hello, myself Yusuf and welcome to the video about foundation design in SAFE. This is my load for column. First there is a dead load and after that live load for different column. And this is my column arrangement C1, C2, C3, C4, C5, C6, C7, C8 and all. And C1 has a 500 by 500 column, C2 has a dimension of 500 by 100, C3 500 by 500, C4 500 by 500 and all C1 to C12 has a dimension of 500 by 500 and C13 600 by 600 and 14 has 600 by 600, 15 600 by 600 and 16 has a 600 by 600. Means all the exterior column has a size of 500 by 500 and all the interior column has a size of 600 by 600. As you can see, this is a table of column load, dead load, live load, material of column M40. C1 column number C1 to C12 has a size of 500 by 500 and all and C13 to C16 has a size of 600 by 600 and all column have a material of M40 grade and rebar of HYSD 500 and this is a different loads for different column. And this is the our column arrangement C1, C2, C3, C4, C5, C6, C7 and all. Now we will model foundation for the building in the SAFE 2016. Here you now can we have see to define I have material. Already opened the SAFE. Go and define material file, click on new material. Here change IS 456 M40 design preference, material type concrete, cover 50 mm 25, model velocity for prefer bar size 20 mm, 5000 under root FCK 31622.776 Panzer ratio. We need to change 0.55 metric default specified concrete. Okay, and click on read only. 40 total number of strip is 90 material. Total number of read HYSD 500, grid spacing 1 by 1 meter, rebar 77, click on OK. 21 nuances 500, tensile 545, click on OK. Now define slab properties, add new property, mate slab material M40. Here mate thickness you can start with a 500. Okay, click on OK. Now define column properties, new properties. Column has two size 500 by 500 and 600 by 600. So first 500 by 500 M40 500 by 500. Okay, here add copy of property column 600 by 600 600 600. Okay, click on OK. Now define soil subgrade property. Soil subgrade property, soil we have 2.5 into 10, so 250 bearing capacity of soil. Click on OK. Now we have to define a load combination, a new combination. First combo u ultimate plus live load 1.5 strength. Okay, add new combo for service, combo service dead 1 live also 1 service. Okay, and click on OK. Now we have to draw a slab. So on here select property mate, now we have to go on edit area, expand and shrink area, extension of 2 meter means 2000 mm. Click on OK. Now we have to draw a column. Column has a size of property above, column 500 by 500, 0 2 3, height above 0, property below none. Okay, first 500 by 5, all the exterior has a size of 500 by 500. So interior has a size of 600 by 600. Sorry. Okay. Now next step is to draw a column design strip. So first strip, column strip, here 3 3 3 3. Now we have to assign a material to slab and design strip. So select and go on design, select SYZ 500. This is for slab. Now for strip, Now next step is to assign a support data to the slab. Assign support data, soil properties. We have defined. Okay. Now next step is to assign a load to the column. Assign load data, point load, dead load for C1 893. Here size of punching shear 500. Okay. Similarly assign live load. Live load value is 436. Now C2 column assign load data, dead load C2 for C2 2479 2480. Okay. Assign load data, point load, live load value is 1309 means 1310. Okay. Now similarly assign load to all the columns. Now I have given all the loads to the column dead load and live load both and save the model. After that on CD, this is live load, display, show load. This is show loading value. This is dead load, live load for the whole column. Now next step is to design next step is to analysis the, so go on run analysis. So this is our displacement due to dead load. Now we have to check the punching shear, so go run analysis and design. Now go on display punching shear. Here all value is greater than 1, so we have to change the depth of the slab. So for changing the slab thickness we have to unlock the model. Now go on define slab property, modify shore property. Here we have to change the thickness to 900 mm. So okay, click on OK. Now again run analysis and design. So this is now displacement due to dead load. Now go on display, show punching shear design. Again interior column has a punching shear value greater than 1, so again we have to change the slab thickness. So go on unlock the model, define slab properties. Now 1200 mm thickness. Okay, again go on run analysis design. Okay, now go on display punching shear design. All the column have a punching shear value less than 1, means safe. Now go on display, show strip forces due to load combination, moment, load combination due to layer B is shear forces, torsion, axial forces, no axial forces, display slab forces and stresses, slab moment, forces, display crack widths, to at bottom face to ultimate combination, top face service for service load combination, bottom face. Okay, now go on display, so slab design, here impose minimum reinforcing layer A, click on apply. This is the top and bottom reinforcement data, bottom reinforcement required. Similarly, we can also see for layer B. Minimum top and bottom reinforcement required in column strip. Now go on slab forces and stresses. We can also check for maximum moment, maximum moment, minimum moment, maximum shear force. Okay, now next step is detailing, so go on run detailing. You check all these and run new detailing. Okay, go on drawing component views, slab view, framing plan, rebar table, number. Now rebar schedule, type and size of number of bars required, length of the bar, total number, bill of quantities, bar size 10 mm diameter, bar length required, its turn in metric ton. Now in the slab view, rebar plan, number of 5, top rebar plan, bottom rebar plan, reinforcement profile, layer A, layer B, section 2, number of bars, section 1, bottom rebar plan, okay. So with this we have completed foundation design in SAFE. Thank you for watching.